Tough luck for all you in the audience, LOL. No blinking is allowed during this film. JK, you are all on a high-speed experimental thought project dense with high-concept mental stimulation to make your brain throttle at its absolute maximum. It was created simply to explode your head. Be warned.
Today we're going to introduce you to Plato's theory of organicism and take you on a journey in pattern from the subatomic level to the scale of the observable universe. Then, utilizing current-day science, we're going to melt it down to our own brain-dagger theory on everything. Needless to say, it's kinda complicated. Let's get started with a quick definition of the word organism. This is a complex structure of interdependent and subordinate elements whose relations and properties are largely determined by their function in the whole. Organicism is the position that the universe is orderly and alive, much like an organism. According to Plato, the demiurge, an all-powerful eternal being that manipulates patterns across all of existence, created a living and intelligent universe. It was known as the world animal. We're going to explore what today's accumulated knowledge has to say about the universe as organism. You might want to hold on. But first, some doom and gloom. The world that exists today can certainly be seen as a land of danger and uncertainty for humankind. Tragedies and disasters are unfolding everywhere with no end in sight, and the planet looks to be falling into a state of instability faster by the day with the changing climate. When taking the viewpoint of this world as a dangerous place full of violence and unpredictability, people have the right to be nervous about daily life. This is the existence most humans see through the only vantage point they have, their 5 senses. However, there is much more to the world than exists beyond what our brain can translate of reality. Most of what occurs in this world is invisible to the human eye. We can only view a tiny percentage of what is truly occurring around us, and therefore can't even remotely comprehend the context of what we are seeing with our bare eyes. To genuinely understand the world, we must be able to envision what is actually going on within every level of scale. As much as our bodies are made up of billions of smaller organisms, we too may be part of a series of much larger organisms. The universe is far more balanced and harmonious than it could possibly seem from our truly basic point of view. Let's hear what Alan Watts had to say about it first.
Now, we come here right at the start to an extremely important principle, which is the different points of view you get when you change your level of magnification. That is to say, you can look at something with a microscope and see it a certain way. You can look at it with the naked eye and see it in a certain way. You look at it with a telescope and you see it in another way. Now, which level of magnification is the correct one? Well, obviously, they're all correct, but they're just different points of view. You can, for example, look at a newspaper photograph under a magnifying glass, and where with the naked eye you will see a human face, with a magnifying glass you will just see a profusion of dots, rather meaninglessly scattered. But as you stand away from that collection of dots, which all seem to be separate and apart from each other, they suddenly arrange themselves into a pattern. And you see that these individual dots add up to some kind of sense.
This may lead one to ask the question, what are we as people actually made of? We asked Matt Leinart, an evolutionary biologist, what he had to say about it.
We tend to think of ourselves as, well, I'm a person, I'm a human, but really there is more non-human about you than what is actually human. So it's predicted or it's estimated that only 1 of every 10 cells that makes you is actually a human cell. The rest of it, the other 90% is bacterial. So you are primarily bacterial and less human than what you might think.
Just as the flame is the streaming of hot gas, just as a whirlpool in a river is a whirling of streaming water. There is no thing that whirlpools. There is the whirlpool, and in the same way, each one of us is a very, very delightfully complex undulation of the energy of the whole universe. So in this way, very fast impulses are looked upon us as constant. And we see where there are fast impulses a solid thing. When you look at the blade of a propeller or an electric fan, the separated 4 or 3 blades become a solid disc, and you cannot throw an egg through it. Well, so in exactly the same way, you can't put your finger through a rock, because the rock is moving too fast for your finger to go through.
So, if everything we touch is just particles zooming around in space, why does everything feel so solid? We talked with PhD student Ray Garner about the recesses of the tiny invisible world.
The reason a rock or just the stool I'm sitting on or anything that you feel is solid is because of electromagnetic repulsion. As you know, my 2 hands, they obviously are made out of atoms. They've got electrons orbiting their nuclei. As my 2 hands come together, what I'm actually feeling, what my brain interprets as feeling, is the electromagnetic repulsion of the electrons in this hand repelling the electrons in this hand, and that's what stops it. The electromagnetic force is, on the grand scale, one of the strongest forces of the universe. Gravity is such a weak force. Electromagnetic is really where it's at. And so that's how things feel solid when you touch them, because you're actually bouncing off of their electrons in those atoms.
Now let's take a look in the other direction, outward. As we zoom out of the human body, we will find buildings, streets, and vast cityscapes. These are all made up of millions of people, cars, and structures, with a system for conducting energy as electricity and combustion throughout the entire structure. After that, we can zoom out to countries made up of thousands of cities and open spaces, connected by the bloodstream of the highway and the lungs of air travel. Moving on, we would find ourselves at the planetary scale. The Earth's energy cycle is comprised of forces such as ocean currents, subduction and convection, weather currents, and the water cycle, all powered by the sun and the core's own radiation. Next, we would arrive at the solar system, powered by sunlight, dark energy, and gravity. After saying goodbye to our view of Earth, we can zoom out further to the Milky Way galaxy, which derives its energy from the supermassive black hole at its center. Zooming out even further, we would arrive at clusters of galaxies, then superclusters, then the entire observable universe, which is powered by the Big Bang. The same as microscopic particles are invisible to the human eye, this level is too large to be seen unaided. What comes after that, we simply don't know.
All energy for life, right, stems first from the ability for organisms to do photosynthesis, to capture energy from the sun. Because that energy that's captured from the sun will be the energy that's used to fuel all the rest of life throughout the food web. You can look at land plants, right? Capturing that energy from the sun, using that energy, right, to fuel photosynthesis and to build molecules of sugar, which is what they're doing. And then, of course, then organisms eat those plants, and that's then how they harness that energy. If you look at the ocean, it'd be like phytoplankton, right? Which are responsible for over half the oxygen we breathe. You're gonna have this energy that's gonna be moving through this food web, through this system here that starts with photosynthesis, but then moves on to these heterotrophs, or these organisms that have to consume other organisms in order to acquire their energy for their own metabolic needs.
one can see the countless connections and intricacies that keep the Earth's life cycles going. But the fact that there is life on Earth at all is much more complicated when you move up to the galactic scale. The levels of coincidence that brought us into being can be staggering when revealed.
That delves sort of into an answer to the Fermi paradox, which is the question, where is everyone? If the universe is full of beings like us, where is everyone? We should have contact. And one of the answers to that paradox is called the rare Earth hypothesis. That life on Earth is just this huge coincidence after coincidence of improbable things happening, that we are the only ones in the universe. We're in the galactic habitable zone. We're the right distance away from the center of our galaxy for stuff like us to form. We're also not close to the center where there's a lot of gamma rays and X-rays that would just irradiate any chance of life here. We're also in the stellar habitable zone. We're the right distance from our own star to where water is liquid. Venus, just outside the habitable zone. Water cannot exist, it's too hot. Mars is just outside the habitable zone on the other side, where it's too cold, it'll just be ice. We also have a very large moon. Back in the time of the dinosaurs, the length of the day was 8 hours. The moon has actually gravitationally slowed the rotation of the Earth. To where we get this nice 24-hour day. We also have volcanoes that constantly take the minerals and the energy from the Earth's center and pump it into our atmosphere, pump it into our soils to where that can then be used for life to feed on. There's tons and tons of a series of seeming coincidences that have allowed life to exist here.
And while these massive objects directly affect our ability to live on Earth, there are just as many seemingly inconsequential organisms, such as bees, that are just as important.
The importance of bees really comes along with their role in pollinating systems, right? Pollination and allowing plants to reproduce. It's been said that without the pollination from bees, that we would lose maybe about a third or a half of the diet that we normally have.
Just imagine if we lost half of our food supply, the world would fall into a series of global catastrophes, with war and famine rapidly taking hold of all of our lives. So what role do humans play in this web of energy? Do we take from or give to the orderly chaos of the universe? The answer may be both. How do we make sense in the grand scheme of things?
You may add up to some kind of sense that is not apparent to you in your ordinary consciousness. When we examine our bloodstreams under a microscope, we see there's one hell of a fight going on. All sorts of microorganisms are chewing each other up, because the health of our organism depends on the continuance of this battle. What is, in other words, conflict at one level of magnification is harmony at a higher level. And could it possibly be, therefore, that we, with all our problems, conflicts, neuroses, sicknesses, political outrages, wars, tortures, and everything that goes on in human life are a state of conflict, which can be seen in a larger perspective as a situation of harmony?
Any organism, right, is going to have systems to it. Systems that keep things in homeostasis or some sort of physiological balance to them. And for us humans, it might be, having a circulatory system, a respiratory system, and so forth. But just like having all those different compartments that work together for the same general purpose of keeping us alive, it's the same thing with the Earth. The Earth is composed of all these different ecosystems, and even though you have all these different ecosystems, they're not isolated ecosystems. They work together where the health of one ecosystem impacts the health of another ecosystem, and all of these work together to keep the Earth at sort of a specific temperature or specific oxygen content. And this is what separates Earth from a lot of our neighboring planets like Mars and Venus. It's actually the fact that we are this living system, and because of this, life has an enormous impact on Earth's overall biosphere and on Earth's atmosphere. And life is actually acting on the Earth and keeping Earth sort of in this physiological check.
But how did this cycle of energy get started?
As you might have noticed, Earth has a lot of water. We have no idea where that water came from. The early history of the solar system, at the distance that we are to the sun, that's too hot for water to condense. But thanks to all those comets out in the outer solar system where it's much colder, where it can't be ice, and Jupiter sending them into the inner solar system, all of those comets were able to hit proto-Earth and deposit their water ice onto Earth to then later melt, form the atmosphere, form the oceans and whatnot.
We tend to see the universe itself as really consisting in all the stars and galaxies. That's what it is. That's what we notice. But the space in which all this happens is sort of written off as something that isn't really there. But what one has to realize is that the space is an essential function of the things in the space. After all, you can't have separate stars unless there is a space around them.
This is important to note for a variety of reasons, one being the fact that empty space or the air is not empty at all.
You have all these microscopic things in the air, but it's only recently that we're starting to really appreciate what might be in the air as in living organisms, because a lot of what we know about, let's say, bacteria, for instance, right, they might move in wind currents short distances, for instance. But what we're finding is that there is some evidence that suggests that maybe there's actually an ecosystem in the atmosphere itself that where these bacteria can live. And again, it's going to take some further work to determine, are these bacteria that are sort of stuck in currents and will make their way back down, or are these bacteria actually surviving in the air, reproducing in the air, and just staying up there? And there is some evidence to suggest that that might be the case.
That we screen out the perception of space as an important reality. Just as we pay attention to the figure and ignore the background, so we see one way of looking at things, namely that the organism is very frail against the environment. It lasts a long time, the environment, but the organism only lasts a short time. What do you mean the environment lasts a long time? What does the environment consist of? Just a lot of little things.
In the air that we breathe here on Earth, there is 10 to the 25 atoms and molecules buzzing around in the air that we breathe. So empty space isn't actually very empty. It's actually this bubbling, churning, cosmic foam, that's what they call it, where we've got a bunch of different fields, and as these fields interact, a particle pops out. So the photon field interacts and we get a photon. The electron field does something and we get an electron. And we've got all these fields creating all these different particles. Now, we know a lot about these particles. As a standard model of physics, we can tell you anything you want to know about an electron. But what we don't know about, and what also is probably in this cosmic web, this cosmic soap, is dark matter and dark energy. I will preface that by just saying, just because we named something doesn't mean dark matter is matter and dark energy is energy. We have no idea what either of the two are. Whatever those two things are, that's also there in not just empty space, but in the air that we breathe as well. So empty space isn't really empty on a quantum level. It's this weird foam of particles coming into and out of existence randomly, quadrillions of times a second.
To a person who really wakes up, you very soon realize that your existence is not something that is just the hopeless little creature that's suddenly confronted with a great big external world that goes gah at him, and eats him up. Every tiniest little thing that comes into being, every minute little fruit fly or gnat or bacterium, I will go so far as to say is an event upon which this whole cosmos depends. This thing goes both ways. It's not only that every little organism which exists depends on its total environment. The reverse is also true, that the total environment depends on each and every one of those little organisms. So that you could say this universe consists of an arrangement of pattern in which every event is essential to the whole thing.
These patterns and designs form by a process known as self-organization. This is where some form of overall order arises from local interactions between parts of an initially disordered system.
Self-organization is found at so many different levels. You can have it at the molecular scale with self-organization, but you can also have the organismal scale where you have, for instance, flocks of birds, right? Or schools of fish. These are also considered examples of self-organization where they are oriented in some way that does not appear to be some sort of random orientation, but something that is sort of selected for.
Galaxies are very self-organizing. They're in a constant cycle of using up the gas that is inside them while also collecting gas from outside of them as gas falls onto their disks. They also expel some gas as supernovae or active supermassive black holes at the center of their galaxies propel gas outwards. And then other smaller galaxies, or even larger galaxies, like the Andromeda will collide in the Milky Way, galaxies will collide and merge their gas, and then use that gas to form stars and planets and whatnot.
With animal markings, that can be an example of self-organization where you have patterns that are found on organisms, on the skin of organisms, that provide some sort of adaptation. And adaptation, by definition, is a trait with a functional role. So, for instance, with zebra stripes, it appears to be some sort of self-organization there. You have this pattern of black and white, and it has an adaptive role in actually helping preventing it be bitten by insects. It keeps flies away by having that pattern there.
This all fits in with an equation found in nature known as the Golden Ratio. This is the ratio of a line segment cut into two pieces of different lengths, such that the ratio of the whole segment to that of the longer segment is equal to the ratio of the longer segment to the shorter segment. Here's how it works.
Some plants have found a way in order to stack their leaves according to the Golden Ratio. Whether the plants know they're doing it or not is a different story. So where as they grow and leaves start to get stacked up on top of each other, they're arranged, they're rotated in such a way that every leaf is getting sunlight, allowing plant to use photosynthesis, produce food for itself. That's way better. It expends way less energy doing that than creating a leaf, then putting another leaf on top where this bottom leaf is just useless now, so it's not getting the sun. So it's all about expending the lowest amount of energy. It just so happens that we get these nice repeating shapes and patterns in nature all over the place. Nature just doesn't want to do a lot of the work.
Hand in hand with self-organization are fractals, infinitely complex patterns that are self-similar across different scales. They simply repeat a mathematical process over and over in an ongoing feedback loop.
When you're dealing with fractals, you can have fractals in the shapes of galaxies. You can have these patterns with the Golden Ratio, which is a famous fractal. You can have fractals in all kinds of things, but you can also have fractals in living organisms. And fractals stems from chaos theory. And it's one of these examples of fractals where you can have an unrepresented pattern, but requires closer inspection to find out that there actually is a pattern there. And that pattern is one that is repeating itself. And in biology, we oftentimes find this where what's found at the macroscopic, let's say for instance, a tree, you look at a tree, you see the trunk, you see the big branches coming off of it. But then if you were to just look at just one of those branches and focus on that has the smaller branches and stems coming off of it, that also looks like a tree. But then if you look at just one of the smaller stems with the leaves coming off of it, that also looks like a tree. So you have this repeating pattern throughout it, okay? The same thing you could say with a nautilus shell, how it's going around and around, the Golden Ratio, and you find this repeating pattern that's a mathematical expression that's happening there.
I feel that astronomers become aware of the most astounding fact of the universe, and rarely do other people get to learn it. And that is that the atoms in your body were formed billions of years ago in the crucibles of these stellar furnaces that fused hydrogen into heavier elements, carbon, nitrogen, oxygen, all the things that we're made out of and we breathe and eat and all that stuff. And these high mass stars in their later years exploded, scattering their enriched guts across the cosmos, material that will later go on to form the next generation of stars with orbiting planets. And on those planets would be all the fundamental ingredients for life itself. And so when you look up in the night sky and you think, wow, the universe is so big, I must be really small, turn that back around. Your atoms are made from the universe. You are a part of the universe. Literally, you are made from the universe. You are stardust. So when I look up at the night sky, I don't feel small, I feel big, knowing that my atoms came from those stars. And that is the most astounding thing.
So let's say the tree which grows apples is a tree which apples, using apple as a verb. And a world in which human beings arrive is a world that peoples. And so the existence of people is symptomatic of the kind of universe we live in. So our popular speech reflects it. We say, I came into this world. You didn't, you came out of it. Billions of years ago, you were a big bang. But now you're a complicated human being. Depends how you define yourself. You and I are all as much continuous with the physical universe as a wave is continuous with the ocean. The ocean waves and the universe peoples. And as the wave, I wave at you and say, you! The world is waving at you and saying, hi, I'm here. We are as symptomatic of the scheme of things as the apples are symptomatic of the apple tree or the rose of the rose bush. The earth is not a big rock infested with living organisms, any more than your skeleton is bones infested with cells. The earth is geological, yes, but this geological entity grows people. And our existence on the earth is a symptom of the solar system and its balances, as much as the solar system in turn is a symptom of our galaxy. That what I am involves what you are. I don't know who I am unless I know who you are. The whirlpool is something the stream is doing. And exactly the same way, the whole universe is doing each one of us. The whole world is moving through you. All the cosmic rays, all the food you're eating, the stream of steaks and milk and eggs and everything is just flowing right through you. We find, if I've got to put it back into words, that we live in an eternal now. You've got all the time in the world because you've got all the time there is, which is now. And you are this universe.
It may be liberating or terrifying to process this train of thought, but having it in the back of your mind is certainly important. Everything in existence makes you who you are, from the atom to the observable universe. The definition of the word black means there must be a white. We must understand that bad connotes good, outside describes inside, and if you didn't have someone to dislike, you wouldn't be someone you love. The fact that things are so different simply describes their similarities. Understanding the other side's point of view is of the utmost importance, as confusion and misinformation could be said to have caused more death and destruction by far than anything else in the history of humankind. The definition we are using for the universe as an organism is as follows. Organism, a complex structure of interdependent and subordinate elements whose relations and properties are largely determined by their function in the whole. The problem with calling the universe an organism is this: we don't yet know what the function of the universe is. Organisms all share one thing: a purpose. If every component in every smaller scale has been functional in a larger scale, unknowable to that component, why would it end with the observable universe? For instance, ants cannot comprehend the concept of the earth and stars, no matter how frenzied they send chemical signals back and forth. If we ever find out what the universe is part of on a larger scale, it would revolutionize everything we know. Is the universe simply a grain of sand on a cosmic beach? Is it an experiment with the very laws of nature in a mind-boggling child's science fair? Whatever the universe is here to do, it's hard to believe it's not a part of something much larger. It's tough to grasp that if bees and atoms are so important in the overall scope of things, that all the energy in the universe serves no goal beyond itself. Thinking about what lies beyond is certainly a thought experiment on the grandest scale. We may never know what is out there, but it sure is a joy to imagine. However detailed all of this information may seem, the magic to the brain dagger theory of everything is this: it's meant simply as a suggestion of a mindset, which you are all the more welcome to shape for yourself. And that, my friends, is our argument for the universe as organism.